So we're going to divide and conquer here. We're going to do two things. We're going to first learn about the art of formulating a linear programming problem. And then after we do that a few times, we will then focus on solving the problem. So the first thing you need to get through your head is that when we start to formulate, you need to try to avoid thinking about what the solution is or what you think it might be. Instead, we need to think about abstracting all the important parts. So the parts that are important are shown here on this slide. So the approach that I want you to take to formulating, many times I'll give you a word problem or a word description. So you need to read that problem once to get a general idea, and then, heaven forbid, you should read it a second time. This time you should try to identify four big things: the decision variables, the objective function, the constraints, and the data elements. So remember, the decision variables are the things that the decision maker has control over. We're going to write them in mathematical symbols representing usually levels of activity. It's what we need to determine. So we're going to look first at some product mix examples, which is we're producing different products, multiple products, and we want to know the mixture, how many of each, to produce. So there we would want to try to define the decision variables in a way that we know how much of each product to produce. Then we want to think about the objective function. This is the thing it's our goal, the thing we're trying to optimize. It has to be a linear relationship, remember. And a lot of times this is maximize profit or maximize revenue. It might also be minimize cost or minimize time. And then we also want to look for constraints. So these are the restrictions, usually on stuff like a resource. So it might be raw material, it might be time, it might be money, things like that. So it's a restriction on a lot of times our resources. So we can also have, in addition to those kinds of structural constraints, we may also have binding relationships. So this includes bounds. So we might have lower bounds. So for example, for producing products, we probably cannot produce a negative number, so we would have a lower bound of 0. But we also might have an upper bound where there's some decision from upper level management that says we should not produce more than so many of this particular product. And what I want you to do is attach a word description to each, and I'll show you what that means in just a little bit. And then finally, we should also be trying to extract the data elements out of that word description. So these are the numbers that go in front of the variables, the coefficients. All right, so it's that $5 if we're selling a clock, $3 if we're selling a radio, or whatever it is that we're doing. Right? Some people find it very helpful to write what they think these things should be in words first, especially for the decision variables and the constraints, and then go back and translate that into a mathematical formulation where we're using mathematical symbols. So here is the outline that I want you to follow. You define the decision variables, define the objective function, and then define the constraints. So then I should take the form of let dv1 equal decision variable 1, dv2 equal decision variable 2, dv3 equal decision variable 3, however many variables we need, and then maximize or minimize that objective function subject to the constraints. And then the constraints in braces next to it, I want you to put a word description. That way you remember what that constraint represents, and it's also easier for us than put it over into Excel when we start to solve it. So for the decision variables, often we use a lowercase letter to represent it. So if we were making clocks and radios, it might be let C equal the number of clocks to produce during the next production cycle. Let R equal the number of radios to produce during the next production cycle. And then we have some objective function and some constraints. All right, so next up we'll look at a couple of examples of formulating a couple of problems.